Okay, my viewer, today we are going to see about the greatest integer or step function or the so-called the floor function. The floor function or the step function is denoted by f of x equals the greatest integer x. So this means it is the greatest integer less than or equal to x. It is less than or equal to x. If we take any real number x, we can find the value of x by taking an integer which is less than or equal to x. For example, if we take the greatest integer of 3.4, how can we evaluate this one? That is, the greatest integer of 3.4 is we take any real number, we take any integer which is less than 3.4. That means let's list integers which are less than 3.4. So 3 is less than 3.4. And 2 is less than 3.4, 1, 0, and so forth. So 3 is the biggest or the greatest integer. So the greatest integer of 3.4 is 3. At the same time, if we take 10.7, the greatest integer of 10.7 is 10, because 10 is an integer which is less than 10.7 and it is the largest one, or it is the greatest one, or it is the bigger one, it is the biggest. So the greatest integer of 10.7 is 10. If we take a negative number, for example, the greatest integer of negative 3.2, let's list an integer which is less than this number. So an integer which is less than this number is negative 4, and negative 5, and negative 6, negative 7, and so forth. So this one is the greatest. This one is the greatest. So the greatest integer of negative 3.2 is negative 4. So don't say negative 3, because negative 3.2, 3 is greater than negative 3.2, not less than. So, and let me give you another example, negative 5.6. The greatest integer of negative 5.6 is negative 6, because negative 6 is less than negative 5.6, and it is less than negative 5.6. So if we list this integer which is less than this, so negative 6, negative 7, negative 8, and so forth are the integers or negative integers which is less than negative 5.6, but the greatest one is negative 6. So in a simple way, the definition of the greatest integer function seems this one. And next, we will draw the graph of the greatest integer function or the state function, and we will see some equations involving the greatest integer function. Let's see. Next. And now let's draw the graph of f of x equals the greatest integer of x. To draw the graph of the greatest integer x, let's try to fill this table. Now this is x and this is f of x. Now negative 2 is less than or equal to x, and x is less than 1. Let's take this one. And negative 1 is less than or equal to x, and x is less than 0, 2. And 0 is less than or equal to x, and x is less than 1. And 1 is less than or equal to x, and x is less than 2. Now, if we take any negative number between negative 1 and negative 2, we obtain negative 2. It's obvious, because the greatest integer of negative 1.5 is negative 2. And any number which is in between 0 and negative 1 is negative 1. And this one is 0, of course. And this is 1. And you can take uh, many intervals. So let's take the graph of this step function. Let's see the graph of the step function. Now, let me take this is 1, and this is 2, and this is negative 1 and negative 2, and here this one is negative 1, and here negative 2. Here we have 1 and 2. Now, When x is negative 2, when x is negative 2, we do have negative 2 here. We have negative 2. So any number in between negative 2 and negative 1, the functional value is negative 2. So till here, we have this. We have this. But when it is negative 1, when it is negative 1, it is negative 1. It is negative 1, it is here. Not here. Not here. So we make this part whole. We have to make it whole. So from negative 1 to 0, the value is negative 1. So till here, it is negative 1. So here, when x is 0, when x is 0, it is 0, not negative 1. So we have to make this one whole. And when x is 0, it is 0. From 0 to 1, it is 0, of course. So we make this one. So when it is 1, it is 1. It is 1. It is 1, not 0. So we have to make this whole. So from 1 to 2, it is the value is 1. So like this, like this. So when it is 2, it is 2. It is 2, not 1. Therefore, we make whole and so forth. It continues like this. So this is the step function. The step function. So the domain of this function is the set of real number, and the range of this function is only integer values. So the graph of step functions or the greatest integer functions looks like this one. Thank you for today. And next we will see equation involving the greatest integer function. Thank you for now. Okay, to find the greatest integer of x, now we use the formula, this one. The greatest integer of x, this equals m, this means, this implies, or this, if and only if m is less than or equal to the x, and x is less than m plus 1. So from the greatest integer of x is equals to 4 is the same as 4 is less than or equal to x, and x is less than 4 plus 1. So this is 4 is less than or equal to x, and x is less than 5. So our solution set is, the value of x is closed interval 5 to the open interval, closed interval for a mean, from 4 to 5, open interval. So if you take any number between 4 and 5, just you give 4. For example, 4.5, the greatest integer of 4.5 is 4, and so forth. So we use this way. This is the first example. Okay, the greatest integer of x plus 3 equals to 7. We can have also the formula that the greatest integer of x is equals to m is if and only if m is less than or equal to x, and x is less than m plus 1. Just we use this formula. So the absolute value and the greatest integer of x plus 3 is equals to 7 is the same ways 7 is less than or equal to x plus 3. X plus 3 is less than 7 plus 1, which is 8. So using this formula, so subtracting 3 from 7, which is 7 minus 3, is less than or equal to x plus 3 minus 3 less than 8 minus 3. So this is 7 minus 3 is 4, and 4 is less than or equal to x, because 3 cancelled by 3, less than 8 minus 3 is 5. So our solution set is in between these two numbers. So x is in between 4 and 5, including 4 and excluding 5. So our answer is 4 to 5 in the open, 5 is in the open and 4 is closed. So this is our solution. Okay, to solve such equation, let the greatest integer of x is equals to z. So we have 2 plus z, the greatest integer of 2 plus z is equals to 5. So based on our rule, 5 is less than or equal to 2 plus z, and 2 plus z is less than 5 plus 1, which is 6. So subtracting 2 from these numbers, and 5 minus 2 is 3, and 3 is less than or equal to that. So when 2 is cancelled by 2, and 6 minus 2 is 4. But that means it is the same with the greatest integer or the floor of x. Therefore, 3 is less than or equal to the greatest integer of x, and the greatest integer of x is less than 4. So the value is in between the greatest integer of, since x is this number, or this is an integer, a number which satisfies this inequality is only 3. Only 3. Therefore, the value 3 is, we can take as 3 is less than or equal to x, and x is less than 4. So our solution set must be in between 3 and 4. So the closed interval 3 to 4 is our solution set. So if you take 3 here, 2 plus 3 is 5. So the greatest integer of 5 is 5. And if you take 3.9, 2 plus 3.9 is 5.9. And the greatest integer of 5.9 is 5. Therefore, our solution set must be this one. Thank you for today.